Hello, Honors Geometry students. Welcome to our lesson on isosceles triangles. Our essential question is, how can I solve for measures in an isosceles triangle? As you are going through today's video, I'm going to ask periodically that you pause the video and go to reflect on what you're doing, try out some problems, and then compare. Please make sure that you are doing that as we go along. Today's lesson goes along with learning target 1E, where I can prove theorems about congruent triangles. Okay, so we're going to start with a little entrance question. So here I'm going to ask that you try to answer these three questions, pause the video, and then we will walk through those problems together. Okay, so hopefully you had a chance to pause the video, try these out. Question number 1 says that we are going to write the converse of our statement. Remember, from our from unit number 2, we had an original statement saying that P implies Q. The converse is the flip-flop of that, so it's going to become Q implies P. So we're going to flip-flop the first and second parts of the statement. It says, write the converse of the following statement. If you travel from the U.S. to Italy, then you have a passport. All right, so the first part of the statement is you travel from the U.S. to Italy. The second part of the statement is you have a passport. So if I want to flip-flop those two parts of the statement, it would be something like, if you have a passport, then you travel from the U.S. to Italy. Okay. Question number 2 says, determine if the truth value of the statement and the converse. So the original statement, so if you want to legally travel from the U.S. to Italy, then you have to have a passport. The original statement is true. But the converse, so if you have a passport, then you have to travel from the U.S. to Italy, the converse would be false. And let's talk about why that is in that last statement. It says if they're both true, then we're going to write the biconditional. Otherwise, we're going to give a counterexample. Okay, so we're going to give any example where we have a passport where we're not traveling from the U.S. to Italy. So we could, one counterexample is we have a passport, we choose to stay home for whatever reason. Okay, or we travel to Canada. We travel to Mexico. We travel to some other place where we are required to have that passport. So those are some counterexamples. All right, so the reason we're talking about this converse stuff is because it's going to come up in today's lesson. I want you to realize that just because the original statement is true doesn't mean that the converse is always true. So that's what we're going to focus in on today when we talk about isosceles triangles. All right, so please take a moment here, pause the video, and write down everything that you know about isosceles triangles. All right, hopefully you had a chance to pause the video here. An isosceles triangle, since it's a triangle, we know we have 3 sides. And because it's isosceles, we need to have 2 or more congruent sides. And we have 2 or more congruent angles. Okay, so our triangle has 3 sides. We know we have 2 or more congruent sides. We know we have 2 or more congruent angles. So let's go ahead and mark that up. If we have congruent sides, we mark up sides with the same length using the same number of dashes. Okay, so if those are our 2 congruent sides, then these 2 must be our congruent angles. All right, so this guy hanging out at the top with no marking on it, that's known as our vertex angle. It's the angle that joins together our 2 congruent sides. And then these guys down here, the congruent ones, these are known as the base angles. In this picture, our base angles are at the bottom of our figure, but that doesn't necessarily have to be the truth every time. This guy down at the bottom that joins together our 2 base angles, this is known as the base of our isosceles triangle. Okay, and the other 2 sides, those are often referred to as legs. All right, so let's go through a couple of theorems. So you'll notice that these theorems are 4.1, 4.2, and 4.3. It's because we are dealing with chapter 4 in our textbook, and we're dealing with the first three theorems. So nothing special about the names for these. You're not expected to know the theorem 4.1 stuff, but it would be appropriate for you to know the name of the theorem, which is Isosceles Triangle theorem. And this says if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So what that means is if we come across a triangle where we see two sides are marked as congruent, then we can go ahead and say, hey, since we know we have two congruent sides, then we can mark in that these two angles are congruent. We can add in those congruent angles. Okay. Theorem 4.2 says the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. All right, so let's start. We come across this this figure that has two sides marked as congruent. We know it's isosceles. So this angle hanging out at the top, remember, that is our vertex angle. Okay, if we're dealing with the bisector of the vertex angle, that means we're cutting it into two congruent pieces. So let's just kind of eyeball that in here. If we're cutting this angle into two congruent pieces, we know that we can mark it up with like a half circle dash to indicate that those two angle pieces are congruent. It says that we are dealing with the perpendicular bisector of the base. So since we're perpendicular, we can mark in that right angle. And since we are dealing with a bisector, that means we're cutting it into two congruent pieces. So I can say that this left piece is congruent to the right piece. Notice that I'm using two dashes rather than one to separate it between, to make sure that I can distinguish between my one dash guys and my two dash guys. All right, next one we're dealing with the converse, and it looks like I have a little typo on here. Sorry about that, people. The converse, I want SE here. The converse of the isosceles triangle theorem. So that's the flip-flop of the first one that we saw today. The first one says if we see these two congruent markings for our sides, then we can add in the angles. So the converse says, all right, you're going wrong, and you come across a triangle where two congruent angles are marked as congruent. If we see that much, then we can mark in that our opposite sides are congruent. So if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. All right, so now that we have our basic knowledge associated with this lesson down, let's try to do some sample problems. All right, so example number 1, we're looking for the measure of angle C. If you feel like you are ready for this, then I'm going to ask you to pause the video, solve, and then we'll take a look. All right, so as I'm looking at this diagram, I'm noticing that, hey, I see these two congruent sides marked in there, so I know that I have two congruent angles. All right, so my base angles are congruent. So angle A, this would be known as my vertex angle. Okay, and I know those base angles B and C are congruent. If I want to do this algebraically, okay, I know those are both the same. I don't know what they are, so I can call them X. So I know all three angles of my triangle add up to 180, so I can say X plus 30 equals 180. 1x plus 1x, that's 2x, plus 30 equals 180. I will subtract 30 on both sides of my equation, so 2x equals 150. And then to get x by itself, I'm going to divide both sides by 2. So x is 75. So the measure of angle C, since it's equal to x, is 75 degrees. Okay, you didn't have to set it up as an algebra equation. You could just use that knowledge that, hey, I know that angles in a triangle add up to 180, so I could take 180 minus the known angle of 30 to get 150. I know I have two angles that must be the same measure, so 150 divided by 2 gives me 75. Either one of these methods is going to work for you. One is more based in algebra, and one is just kind of working through the problem-solving process. Okay, so example number 2. Again, if you feel like you have this, please pause the video, and then we'll continue on from there. Okay, so in this problem we're asked to find the measure of angle A. Again, I see that I have two congruent sides marked, so that angles B and C must also be congruent, so angle B must be 50 degrees. Okay, so I don't know the measure of angle A. So if I do this algebraically, I could say something like x plus 50 is equal to 180. 50 plus 50 gives me 100 equals 180. I can subtract 100 on both sides of my equation, and I have my missing measurement is 80 degrees. So the measure of angle A is equal to 80 degrees. Again, you didn't have to put this into an algebra equation. You could just say that, hey, 50 plus 50, that's 100. 180 minus 100, that gives me 80, and do it that way. Okay, moving along. All right, so this is the same type of deal, but now in terms of words rather than in terms of a picture. So what I would suggest that you do here is read through the problem, draw a picture to kind of visualize where everything's going, and then try to solve it. Okay, so hopefully you had a chance to pause the video, and now let's go through and compare and see how we did. It says the measure of the vertex angle of an isosceles triangle is, find the measure of the vertex angle of an isosceles triangle if the base angle is equal to 40 degrees. So I'm going to start by drawing out my triangle. Okay, I know it's isosceles, so I'm going to mark in two congruent angles. It says we're looking for the measure of that vertex angle. The vertex angle is hanging out up here in between my equal sides. We know a base angle is equal to 40 degrees. And I know the base angles in an isosceles triangle are congruent. So I can do this algebraically. X plus 40 is equal to 180. So x plus 80 equals 180. I can subtract 80 on both sides of my equation. So x is equal to 100. So the missing angle measurement is 100 degrees. All right, looking at example 4, now we have to use some algebra because we're solving for a missing variable. In this case, we're looking for the value of y. Pause the video and we'll compare. All right, in this problem, I see that CA and AB, those are my congruent sides. So angle C and angle B must be congruent. So angle B must be 2y plus 7. So to solve for the value of y, I know that all three angles have to add up to 180. And since I've been going through each of these problems in terms of algebra, it's going to be the same deal. So 56 degrees plus 2y plus 7 plus 2y plus 7 equals 180. If you wanted to set it up using the distributive property, so alternatively you could have said 56 plus 2 times 2y plus 7 equals 180. It's going to get you to the same place. All right. So now I'm going to combine some like terms. So I have 2y plus 2y, that's 4y. And I have 56 plus 7, that's going to give me 70 equals 180. I'm going to subtract 70 on both sides of my equation. So 4y equals 110. I'm going to divide both sides by 4. And I end up with 27.5 is the value of y. All right, last but not least, we have example 5. We are looking for the measures of x and y, and we're told the perimeter is 15 centimeters. So again, pause your video, and let's go ahead and we'll compare. All right, so what I see here is that I have an isosceles triangle. Two congruent sides indicate that I have two congruent angles. All right. So I know that x is 60 degrees. All right. I know that my perimeter is 15. So whatever y is, y plus 5 all together has to add up to 15. So y plus 10 is equal to 15. I subtract 10 on both sides, so y is 5. So y is, that missing side length is 5 centimeters. Okay, you might notice that all three of these side lengths are 5 centimeters, so I really have an equilateral triangle. Okay, and I know that all three angles in my triangle add up to 180, so I have a 60-degree angle plus a 60-degree angle, that's 120. So if I take 180 minus 120, that's the measure of this top angle, which is also 60 degrees. So if I have three equal angles, I have three congruent sides for my equilateral triangle. All right, so we just discovered three equal sides, three equal angles there. All right, so take a moment to reflect on what we learned about today. So one or two sentences about what we know about isosceles triangles, how we can solve for missing measurements, maybe work in some vocab with that vertex angle and base angle stuff. All right, and then your job before you come into class on Tuesday is to read and take notes on section 4.2 from your textbook, and then we have a variety of problems to try out. All right, if you have any questions, please let me know. Otherwise, we will touch base again during our first face-to-face class for the week. All right, see you later. Bye.